Okay, so today we're going to continue on with our factorizing of quadratics, but looking at a special case this time. And it's just important that you know the general form of this special case, where it comes from, and how to work with it in the future. So the special case is called the difference of two squares. And it all stems from this diagrammatical representation here. So we have a big pink square, which we can call a squared. Okay. And then in the corner over here, we have a little blue one, which is b squared. And this shows us the diagrammatical representation of a squared take away e squared. Okay. So we're taking the pink square and we're going to remove this blue square in the middle. And when we remove the blue square on the corner, we're still left with this orange part here. And imagine that orange part is picked up and shifted to the side. Okay? If you look at the measurements, okay, this height here, it was of length A, and it had length B removed, so hence this new side here is A minus B. And if you look at this length along the bottom, this is now A plus B, because it was here of length A, this got moved around here, and it got added on to the side there. So what this shows us is that if we have A squared, and we subtract b squared, we are left with essentially another rectangle, which we could express as a minus b multiplied by a plus b. Okay. And these two here are equivalent. Okay. And that essentially is the rule of the difference of two squares. And we can summarize that. That's the same thing as what I've just written, as a squared minus b squared equals a plus b bracket a minus b. Okay. And this is a really nice thing to look out for, to help you factorize nice and easily. And the thing you need to look for to be able to use the difference of two squares is two square terms, a square number or a square term at the start, a squared, and a square term at the end, b squared, with a subtraction in the middle. So if we look at a few examples, okay, we have a square term at the start, x squared, and a square term at the end, 81. So we can use our difference of two squares formula to straight away know that this must be x plus 9 and x minus 9. Okay. We've square rooted a, front of both brackets, and we've square rooted b, end of both brackets, and we can see from our general form that that's the form we're going to have our answer in. Okay. Example 2, 16x squared is a square number, because we have a square coefficient and a square unknown here, and 100 is obviously also a square number. So we need to square root the first term, which is going to give us 4x, and we need to square root the second term, which is going to give us 10. And again, following our difference of two squares, general formula, our answer would look as follows. However, something that we've forgotten with the second one, you're not incorrect in that answer. But I want you to think back, because these lessons are very much building on each other. What did I tell you last week to look for first when you're factorizing when x squared's coefficient is not 1? Okay. Hopefully, you will remember that I told you to look for a common factor. And the highest common factor of both of those two is 4. Okay. So what I would actually expect you to do first, instead of that, is factorize out a common factor of 4. Then in the middle, you're still left with something that is the difference of two squares. This is square, and this is square as well. So then we can factorize fully. Okay. And that is how you would be expected in MCAT and in level 2 to recognize and how to factorize that one. Still contains difference of two squares, but first thing you're always looking for is that common factor. Okay. Last one, square. Just because the square's at the end this time, still following that rule as above. I've done the brackets the other way around. It doesn't matter as long as they're both there. So you can come back to these examples. I'd like you to have a go at these ones, please, in your books. Photograph that and then come back to mark them. Okay, answer